In 2005, NASA created the Ares Projects Office as part of the Constellation program to develop America's next generation of launch vehicles.
Over the past 5 years, the Ares team has leveraged 50 years of space transportation design experience and hardware to provide America with the space exploration capability it needs to move beyond Earth's orbit.
To undertake a task of such magnitude, Ares draws on decades of agency experience from across all 10 of NASA's field centers.
In addition, a strong industry team including ATK, Boeing, and Pratt & Whitney Rocketdyne is supported by subcontractors and hardware vendors from across the United States.
Overseeing this nationwide team is the job of the Ares Vehicle Integration Office. This is a government-led effort employing civil servants and support contractors to perform integrated vehicle design and analysis. Using advanced computer facilities like the Systems Integration Laboratory, the Vehicle Integration Team got its first look at real-time simulations of the Ares 1 flight.
Computer simulations also aided designers in understanding possible mishap scenarios. Researchers examined possible debris impacts and blast wave interaction with the Orion crew vehicle in the event of an Ares 1 mishap.
To date, more than 7,500 hours of wind tunnel tests have been conducted, covering all aspects of Ares 1 operation, from resting on the launch pad to ascent to separation of the first and upper stages.
In addition to its testing, the Vehicle Integration Team has been responsible for ushering the vehicle design through a series of rigorous design reviews, assuring the vehicle design will meet mission requirements.
The Ares 1 first stage element draws on more than 20 years of NASA experience with solid rocket boosters as part of the Space Shuttle. Work is underway on extending these solid rockets to the 5-segment version required for Ares 1 and the 5.5-segment version needed for Ares 5. Ares has worked with the Space Shuttle program to add test objectives and monitoring equipment to several shuttle booster flights and static tests to gather data for Ares 1 use.
New materials and processes will streamline assembly for the first stage. Asbestos-free insulation material and increased automation improve worker safety and reduce the cost of the vehicle by cutting down the time required to build the motors.
The culmination of these process improvements was the test firing of Development Motor 1. The first 5-segment motor built to Ares specifications, DM-1 fired successfully in September 2009.
When test fired, the booster generated 3.6 million pounds of thrust, equivalent to about 22 million horsepower. The combustion reached temperatures well over 5,000 degrees Fahrenheit. The DM-1 test provides significant risk reduction for new motor features on the Ares 1.
The first stage uses a full suite of upgraded avionics for guidance and control. Engineers at ATK began checking out the physical configuration and installation of these electronics in late 2009 in a full-scale model of the first stage forward structures. This simulator allows the Ares team to test out assembly of the completed avionics housings and mounting structures so that the design can be improved for final flight hardware.
The first stage recovery system is comprised of a 3-stage parachute system, with pilot and drogue parachutes preceding the cluster of 3 main parachutes, each 150 feet in diameter. A series of drop tests has examined the performance of all these parachutes, including a full cluster drop in May 2009.
Taking the Ares 1 on the second phase of its journey from Earth will be the spacecraft's upper stage, powered by the J2X engine. Upper stage engineers have conducted extensive testing on the panels that will form the upper stage fuel tanks. These tests optimize the vehicle's strength while minimizing weight to allow for more payload.
The team at Marshall has assembled a world-class friction stir welding capability. This allows engineers to test all the processes and tooling before production of flight hardware begins at Michoud Assembly Facility in Louisiana.
The team also now has the world's largest horizontal multi-axis milling machine, which greatly broadens the horizon for what can be manufactured at Marshall. This tool, which completed acceptance testing in late 2009, will machine domes, structural supports, and bulkheads for the Ares 1 upper stage.
Final testing was conducted on another tool at Marshall in 2009 as well. This robotic system will be used to apply and test the processes, primer, and insulation materials for the upper stage thermal protection system. This system is scheduled for its first spraying of an upper stage test article in October 2010.
The upper stage is also responsible for providing Ares 1 with roll control, keeping the vehicle stable and properly aligned during flight. The team has performed hot fire testing of the candidate roll control thruster and disassembled the thruster to conduct post-firing examinations. Another motor has been tested to settle the liquid propellants in the upper stage prior to the firing of the J2X upper stage engine. These ullage motors have been through a pair of hot fire tests so far.
The Ares 1 upper stage will be powered by the J2X engine. This engine, an upgraded version of the J-2 that propelled the upper stages of the Apollo-era Saturn 1B and Saturn V rockets, burns liquid oxygen and liquid hydrogen for fuel. Marshall engineers have conducted hot fire tests on a variety of components for the J-2X, including subscale injectors and a workhorse gas generator system. Engineers ran 53 individual tests in a variety of injector configurations. The test hardware is designed to withstand an extended test series, while the final flight hardware is expendable.
The culmination of these test activities was the J-2X PowerPack 1A test series. Modifying a test stand at Stennis Space Center used for the Space Shuttle, Ares engineers conducted an extensive series of tests using J-2 heritage hardware. Components for the J-2X PowerPack 2 and first full development engine are being manufactured now. Testing of both will begin in early 2011. The J-2X PowerPack consists of oxygen and fuel turbopumps, the gas generator and related machinery, without an active main combustion chamber or nozzle. To date, more than 2,000 parts have been ordered or already received.
In spring 2007, Ares also began construction of the largest engine test facility built by NASA in more than 30 years. Test Stand A3 is scheduled to be completed in 2011 and will be used to simulate altitude start conditions. As early versions of the Ares 1 elements are built and tested, they will eventually be brought together for integrated vehicle testing. This testing, run by the Flight and Integrated Test Office, is needed to verify Ares 1 on the ground and in flight before it is used to fly astronauts into space.
Marshall's Dynamic Test Stand, originally built for vibration testing during the Apollo program and later used in developing the Space Shuttle, is currently undergoing refurbishment to serve in a similar capacity for the Ares 1. The renovation of this facility, designated a National Historic Landmark, is scheduled for completion in 2010 and will be used for ground vibration testing of full-scale Ares 1 hardware starting in 2011.
On October 28, 2009, Ares took a major step towards operational capability with the launch of the Ares 1X flight test vehicle.
Ares 1X provided valuable information regarding the flight environment, vehicle stability, stage separation, and recovery approach for the first stage. The flight also verified the new ground operations and launch procedures that will be used for Ares 1 at Kennedy Space Center.
Engineers are now analyzing the data gained from over 700 instruments on the Ares 1X, and reports in the coming months will help the Ares engineers in their design for the final flight hardware.
The Ares projects are a nationwide effort, drawing on the talent of thousands from across all of NASA and the American aerospace industry.
Remarkable progress has been made so far over the project's 5 years, pushing the Ares 1 well beyond the concept stage, with hardware at every stage of development, from formulation to design to fabrication and testing. Challenges have been identified and solutions are in work now.
By incorporating NASA's rich heritage of space transportation systems into new Ares designs, the team continues to move forward on an ambitious schedule, developing the technologies and tools to firmly establish the United States as the premier spacefaring nation in the world.